Seth, thank you so much for providing this opportunity for us to present and discuss our hybrid natural language processing classification system on prescription drug abuse. It's such an honor and we're really excited to be here. I'll go ahead and dive into introducing myself. I'm an AI scientist. I work in biopharma where I apply machine learning in the context of drug discovery, as well as the drug development process. Previously, I was a machine learning engineer at Express Scripts, where I applied deep learning in areas such as computer vision and text-based information retrieval. I hold a thesis master's from NYU in biomedical informatics, where my thesis was on EHR text, so deep learning models to predict mortality from clinical text. I was really fortunate to be able to expand on my master's thesis work and implement that work into a scalable real-time prediction model at several NYU Langone hospitals. Dr. Whitley Yee, she's a board certified clinical pharmacy specialist. She works as a specialist at a healthcare tech startup in North Carolina. A clinical pharmacist by training, she completed an ambulatory residency at University of North Carolina Hospital Systems, where her research focused on pharmacy informatics. She also served as an author for the American Society of Health System Pharmacists policy statement, ASHP, on artificial intelligence in pharmacy. Her interests include the clinical considerations and challenges of implementation of artificial intelligence in improving patient care and also advocating for greater collaboration between clinicians and AI scientists. Trevor Mitchell recently graduated with his Master of Science in Data Science from New York University. And is currently open to new opportunities. During his practicum, he built a machine learning classifier to predict churn from real estate using parallel ensemble learning methods. Additionally, he's worked as a graduate research assistant on the NYU Jail Data Initiative, helping to provide transparency into the impact of jailing on recidivism. In this session, we'll be having a hallway style conversation where Trevor will be asking myself and my team member Whitley about our text classification system. We will provide a background on the use of social media in terms of the context of healthcare informatics and some of the challenges that comes with working with this type of data. So Twitter data, social media data, as well as the difficulty of the task. So in our case, we were detecting prescription drug abuse from tweets. We'll also do a deep dive into our approach, and we're going to cover topics in machine learning and natural language processing that touch upon things such as data augmentation, text preprocessing, feature engineering, as well as unsupervised learning such as word embeddings. And then our main architecture, which was using a convolutional neural network for our text classifier. We'll also be talking about broader implications of this type of work. And lastly, we'll end with a question and answer session. I do encourage anyone to ask questions throughout the talk by utilizing the Q&A bar. We will periodically check these questions and we'll try to answer them as appropriate. So I just wanted to first say that this was a team effort. So I really want to thank the team that helped work on this system, although it will just be Whitley and I speaking today. Again, I really want to thank the team who worked on this paper. So with that being said, I know that there are many people on the call, and as a way to interact, I'm curious how many of you all use Twitter. If you do, please put an emoticon in the chat bar. Okay, so we have some users, some users of of Twitter. So that's great. So today we're going to be explaining about how we used tweet data to identify drug abuse, one of the shared tasks from SMM4H, social media mining for health.
That's great. Before we dive into all the technical details, my first question for you is, what is social media mining for health?
Sure. So social media mining for health works as a venue that brings together healthcare informaticists as well as clinical experts to work on systems that are related to analysis of healthcare healthcare informatics in the top with use of social media data such as Twitter and Facebook. Facebook data, some of the topics that they're interested in include monitoring things such as virus spread, using social media, drug abuse incidence monitoring, and disease surveillance and patient education analysis, as well as more topics. So.
See, so I understand that your NLP system was the winning system for a shared task that social media mining for health presented. Can you give us a bit of background into the challenge? And what kind of Twitter data did you work with? And what metrics were used in your competition to evaluate your model?
Sure. So for an overview of the shared task, we'll dive a little bit deeper into what each of the class definitions are. But essentially, we were working on a multi-class text categorization of tweets. There were 4 different classes. So one was the abuse class. So these were tweets that were mentioning prescription medications as being indicative of potential abuse and misuse. There was also consumption and non-abuse, as well as mention only tweets and unrelated reference, so class U. Many of you probably know this who are on the call, but multi-class just refers to text categorization where only one of the observations, one of the tweets can only belong to one of the classes. So there's not overlap between the classes. It's not a multi-label situation. The evaluation metric used was the F1 score only for the abuse and misuse class. So here I show the training and validation set, the number of tweets that were within each of the categories, as well as their representation. So the abuse class was only at 16%. Just as a reminder, the F1 score is kind of seen as the harmonic mean between both precision and recall. We use this F1 score on our own augmented validation set to kind of fine tune our models as well. It's a really useful metric when you're trying to evaluate your model's performance on categorizing a class that may be lower represented. So, not, in our case where abuse is only about representative of 16, 15% of the data set.
So we have a nice definition of the task, and we understand how the model was evaluated. Can you provide us with a bit more insights into the various classes a tweet might be identified as?
Thanks, Trevor. Happy to go into this a little bit more. So as Isabel mentioned, that we had 4 different classes, and and so this is a little bit different than some of the other research that has been done that specifically looks at just abuse versus non-abuse. So in this case, we wanted to more granularly see whether something was completely unrelated, whether it was just a mention, or whether something was consumption, but for a medically appropriate indication. And then the interesting thing though was the abuse and misuse, because that included both of those. And so we're not looking just at abuse, but also any potential misuse. And so the reasons and we'll go to the, if you want to go to the next slide. So I'll just briefly touch on like some of the reasons why this is a challenging problem, given the classes we're looking at. And so abuse, when we talk about like abuse of a medication, so that generally involves taking a drug in a harmful way or a way that's detrimental or results in personal, professional, social problems. And then misuse, however, is when you take a drug in a prescribed way that was not intended. And this could be either intentional or it could be accidental. So even if something as simple as like forgetting to take a dose of medication actually falls into that definition of misuse. So it's extremely broad, which is very interesting. Keeping these two definitions together. And so just to give it like a high level overview of everything that could potentially cause a drug to be categorized as misuse or abuse. When we think of the drug, so the first thing you think about is like the method of attainment. And so you can obtain something legally through a prescription or illegally. So whether you're buying or selling, that's fairly obvious, but even just obtaining it from a friend, right? So even something that maybe you've taken before, but you're just getting it from someone else. If it's not through prescription, then that falls then into the category of misuse or abuse. And then you think about the reason for taking. And so if it's for a medically appropriate purpose or a non-medical purpose, and then the method of consumption. And so this is really where it's about adherence to clinical or to provider recommendations or directions, and includes everything from route, from the the timing of when it. And so anything that could fall under misuse includes taking extra doses, taking it at the wrong time, the wrong route, taking extra, or co-administering it with something else, with another substance. And then the other thing you look at is drug effects. And so even if you are prescribed something for clinically appropriate reason, but you are using it, for mostly a side effect, for example, then that would also fall under misuse. And so the next slide, we do give a few examples because I feel like it's conceptually, it's a lot easier when you can actually like kind of dive in and see what some of these look like. So, so this first one talks about, this is an example of Vyvanse, and so this user is talking about it's being a month and they've gained weight, so now they're going back on Vyvanse and coffee. So in this case, Vyvanse is being used, Vyvanse, which is a stimulant, is being used for its weight loss properties, which is technically a side effect of the medication, and it's not clinical indication. And then whether it was obtained inappropriately, so examples of what that might look like is, when somebody is talking about somebody giving them Adderall, or we found instances where people found medication. So like found an Adderall in my carpet today and set at my computer on Adobe Illustrator for hours and hours, just making stuff. And then also the wrong dose. And so if you double up on a dose, so like doubling up on Prozac, then counts as misuse. Or if you take too much Adderall, gives you the jitters. So that's also taking the wrong dose, or the wrong route. So mechanism of intake. So if something, obviously, something is meant to be oral, but it's being snorted or injected, then that would be abuse or misuse. And then also co-ingestion. So in this case, Adderall and Red Bull, the Red Bull enhances the stimulant effects of the Adderall. And as if you want to go back one or two slides, I'm just going to, so we didn't mention the classification. So this task specifically looked at 5 different drug classes. And these were so they looked at opioids, benzodiazepines, atypical antipsychotics, CNS stimulants, and the GABA analogs. And so these were the medications that are the main data set was looking at. And so we were looking at abuse or misuse of these specific prescriptions. And that's an interesting question. So could you detect a positive example of misuse? And so, yeah, so I mean, anything, like whether it's positive or negative, if it's technically taken as not intended, then yes, it is misuse. And so in that case, like the positive aspect of it doesn't really matter in terms of the actual definition. And then if you want to go.
Sure. And one thing I'll just add, I think that made this task a little bit interesting is that we've seen a lot of other data sets that kind of just focus on, opioids, or just focus on, one particular class. I think that there are, so I'm so sorry. Let me just see. So there are two questions in the Q&A. Okay, so let's look. So I see that someone is interested in the inter-annotator classing agreement. So actually, in just a little bit, we're going to talk about the Corpora development. And then in there, we can also talk about the annotator agreement. So something that, usually when you're developing these medical data sets, you're using clinicians or clinical experts to label text. So people are sitting down in labeling whether or not the tweet is, abuse and misuse, or whether or not it's unrelated. So in just a little bit, we're kind of going to dive into that. We do plan on diving into that.
If I could touch on, I think going forward a few slides, Isabel would then talk about some of the, if we go forward more times. Yeah, so this is another example. So this is where it does get a little bit challenging to make these distinctions, for example, because sometimes, for stimulants, for example, if you may be prescribed, so somebody with diagnosed ADHD is taking the medication, and the purpose of the medication then is to actually help improve functionality. So it's to help reduce the symptoms of ADHD, and so it actually will improve performance. And so that would be an appropriate use. But if it's being, but at the same time, it could also be abused for that use as well. And there's not always enough context in a tweet to know the difference. And another thing is, for example, when you think about like the effects of Adderall, is you may see that, or of any stimulant. So if somebody is saying, like, if somebody's tweeting about using a stimulant to help them stay up all night and study, that counts as misuse. So even if they are appropriately prescribed it, they're not taking it for the right reason. So they're using it to help defer sleep, and it's not meant to be used to keep them up all night. It's just meant to be used during the normal hours. But however, if somebody were to, maybe interpersonal with the way that different people metabolize medications, if somebody were to take it, even earlier in the day, but they may be very sensitive to it, and then have a hard time falling asleep, and so indicate that they're having a hard time falling asleep because they're on a stimulant, even though that tweet would be kind of describing similar things, that they're not able to sleep because they're on it, one would be abuse, or one would be misuse, and one would be just consumption. And so in this case, for example, so we, these in and of themselves it's challenging to label them. And so even, human annotators are going to disagree with, I think, the definitions of this in some of the tweets. And so I just pulled this out because this kind of shows how ambiguous the ground truth labels were. Even when you're talking about co-ingestion, like taking Xanax, which is benzodiazepine, with a coffee, in some instances that is counted as mentioned, but then another time when you talk about taking coffee with a different medication, it's abuse. And so that taking a large coffee with Adderall was labeled as abuse or misuse. But then when you take a double Vyvanse soy latte, which is also another stimulant, that was just counted as a mention.
Yeah, and I think that this speaks to kind of, both working with Twitter data is, one, there's caveats to just the medical side, but also we're thinking a lot about, colloquialisms and also sarcasm. So, these are instances where maybe the annotator kind of saw something as, perhaps being sarcastic versus, really being abuse or misuse. So there are some interesting questions coming up. I think that we have answers to them in our next slide, Whitley, that correct me if I'm wrong, that really go into shedding some light on the data collection, as well as, how many tweets were in the training set. So in terms of the training set, I do have, I did show a little bit here. So our training set, it had about 10,537 tweets. And then also in their validation set that they gave us, there were 2,635. So for Dimitri, I hope that kind of answers that question. And then we'll shed some light on the data collection. I don't know if we want to talk about this first or if we should dive into that. Okay. So
now that we've kind of described the different classes and how challenging the task can be, can you guys go into a bit more detail about how the developers of the data set created it?
Absolutely. So this set was created by O'Connor et al., and they basically annotated the total number of tweets in the set was 16,000. And the way it was created was in collaboration with the toxicology expert who chose 20 prescription medications. And so those are the ones that we had showed previously. And one thing I just want to highlight in this instance is so they chose the 5 medication class and then 20 medications overall in those 5 classes. However, though that list of medications is not comprehensive. And so they're only picking out selectively certain medications in each of those classes. And so I think when we had looked at it overall, you're looking comprehensively at all the medications in the classes. You're looking more close around like 50 different medications. Using the 20 prescription medications, they've been basically used keywords, looking at the proprietary and generic drug names and misspellings to pull, using the Twitter API to pull tweets. And then they also, one thing to note is they did undersample for tweets that mentioned stimulants, because this was very overrepresented in social media chatter. So that was intentionally undersampled. And then we have the inter-annotator agreement below, which was also presented previously. And there were 3 different annotators that worked to annotate this data set.
Yeah, and just to kind of provide some more background in terms of the inter-annotation, there's various methods. Sometimes, for a label to be applied, everyone must agree, or sometimes there's an adjudicator where they make the final call. So that's usually done, especially when we're thinking about data sets that are labeled by clinicians.
So the question of classifying tweets around opioid use has been explored for a few years. Could you tell us a bit about your approach and how your approach differs from the approach others have taken? And why did you decide to go in this direction?
Great question. Thank you, Trevor. So our approach, this slide here is kind of a general overview. I think one, to answer your question in terms of, how our approach differs, I think that, one, we really wanted to use our clinical subject matter experts involved in the process more than labeling the data. So we'll talk about it a little bit later in the post-processing, but we wanted to explore weak supervision and really use our subject matter expert in terms of creating like heuristic rules within our post-processing, but also in terms of even our data augmentation functions. So what I mean by that is that, we kind of discussed before that there are these class-specific information. So we used her knowledge and codified that, which really I feel like sets our pipeline apart. I also think we took a practical methodology approach. So obviously there are really big, everybody hears about BioSTMs for for NLP, we decided to use CNNs. These are really great for instances where morphology really matters, or when you're dealing with short text classification. And in the context of tweets, I think it's up to what, 280 characters, I believe. So that's an instance of short text classification. So that was kind of where we wanted to use CNNs for sure. And we'll go into detail into this much later as well. This is also just an image of our system pipeline. So we decided to use other data sources and use word embeddings, create our own custom word embeddings. And then also with our training data and validation data, we applied text preprocessing, of course, but also we used data augmentation to increase our data set. Then with our word embeddings, we applied fine tuning to kind of fine tune those weights using another ConvNet based off of our task 4 data set. And then we applied our text classifier system, which was a CNN. And then lastly, our post-processing rules.
Thanks, Isabel, for that nice overview of what we'll be able to see. So let's dive into some of the initial activities regarding your solution. As this is a natural language processing project, what did your text preprocessing process look like?
Sure. So our text preprocessing, so this is something that is, explored, and it has a lot, we saw that it made a really big difference in terms of our performance. So how do you pre-process your text? A lot of people here are probably familiar with a lot of NLP techniques where you might tokenize the word or stem the word, lematize it. And, you might mask things such as digits. In terms of for tweets, we use this open source package called Ekphrasis. It's great. Y'all should check it out. It also has a Facebook preprocessor as well. But we decided to normalize for words such as the mention of the URL. So, in other literature, a lot of people just remove the URL in general. And then we also decided to normalize for instances of email mentions, money, the user, the percent, and time and date terms. We were working with a data set that already masked users. So as you can see here, where we're BTS Army, this tweet right here, you see this is an _U. That is actually what the curators of SMM4H task 4, that's how they masked the users, users themselves. But normally you would have that at user, so at Whitley Yee, if we were tweeting to Whitley. So it ends up looking like this. We also used a way to provide emphasis and annotation around certain terms. So rather than stripping out the hashtag like some other tweet preprocessing text or text pipelines that I've seen and read about in the past, we just decided to kind of create emphasis around those words. So you can kind of see that in some of these tweets here. And then also, I think, something like we wanted to normalize our vocabulary. So something like I feel good, that turns into I feel, with the normalized word for feel. And then it was annotated with elongated and these special brackets. So,
So in machine learning in general, the more data you have, the better the model you can potentially create. Can you tell us how you expanded your Twitter corpus from 13,172 tweets to 28,094 tweets? And how did the breakdown of your classes in your data set change from what you had before your data augmentation to after?
Yeah, so that's a great question. So We used one of the data augmentation strategies that is outlined in this, in something called a Snorkel, and also in a paper that's called EDA, which refers to, I can't remember the full paper name, but easy data augmentation techniques, where in that paper, it kind of mentioned by doing things such as replacement of adjectives or synonyms or even different characters can really enlarge your data set. So here, what I have shows actually, the class distributions we were able to maintain that the same. And we were also able to, almost over double the training and validation corpora that we had. So the techniques that we use, here I'm showing a few. So replacing references to relatives. Whitley was critical in this process, where we kind of used her to help us design a lot of these heuristics.
Great.
So we think about the transformation functions. A lot of the transformations we did require creating custom dictionaries. And this was in one instance where we did expand and go beyond just the 20 medications that were listed in the original label data set. And so we replaced, we thought about drug terms, both in terms of names that are like what the proper or proprietary, name of the drug is, likely could be, likely appropriate, or, just consumption, non-abuse, but then also drug terms that likely are more likely to be associated with abuse. And so we separated those out. And so we only replace drug slang or slang terms with other slang terms. And then also we also kept that similar within the same class. And so we didn't replace drug terms or slang terms for stimulants with, for example, benzos. And the other thing is when we're creating the list of slang terms, we use the DEA list that's available. And then we removed it for anything that's ambiguous. So we didn't want to keep anything that would potentially change the label. And also when you're thinking about it, not all the slang terms are really medication specific. And so you could end up turning your tweet into something that, is not even mentioning a drug anymore. And then those are some examples of the ones that we did keep. And then we also did replace proper drug terms with other similar drug term names, again, staying class specific. So Xanax with alprazolam. And then that other example there is actually one that we avoided. So we wanted to avoid, swapping drug terms if it would change the label. So for example, Adderall had me doing literally everything except studying. That was considered abuse. But if we changed it to diazepam, then that no longer really counts as abuse or misuse. So that could have actually changed the label. So that's why we kept it distinct and only within similar drug classes. There's a few exceptions, like a few other terms that we did add in, such as, benzo. So any term that kind of referred to the class as a whole that you may see used colloquially. And then there was a question about medication strength and dosage and masking that. And so that is, I think that's always one of the tough questions, because knowing what the strength is, it can be helpful, if you are trying to look for things that are inappropriate use. But in this instance, if there was a specific dosage mentioned, usually that helped know that was either abuse or consumption. And it didn't actually, most of the times, we didn't actually see a difference in, I think, when I was just manually going through them, most of the times actually knowing the actual dose of the medication wouldn't have really changed the label, because you don't know what the prescribed strength of the medication was to begin with.
Yeah, and I think, sorry, Whitley, I didn't. I would say from a text classification standpoint, we really want our model to be as generalizable as possible. So that is why we decided to mask for number. But if we were thinking about named entity recognition, where we are actually trying to extract dosage, and so forth, we would obviously want to be able to capture and see that. In terms of our model was not as advanced to know when something was in particularly, a dosage that is not normal, if that makes sense. So it was very, very generalizable in that way. So I'm gonna move to the next slide, if that's all right. This just kind of shows in terms of our data augmentation, as it is codified. Sometimes people are interested in seeing this, so I'm just going to skim through very quickly. But as you can see here, just for one function, really we work together to try to make these drug reference data sets, as you can see here. And then we also use part of speech. So, we're looking for nouns in terms of our instances of that. In terms of getting synonyms, we used WordNet, and we followed an outline, as mentioned before, that really just looked at that really followed the data augmentation strategy as kind of provided by one of the Snorkel documentation. Here's another example where we're replacing a similar verb that is a slang that's kind of associated with abuse. So you can see kind of our verb reference data set. And then also we replace similar verbs that are more related to non-abuse. So something like a dose or getting their refill, or, a prescribed mention as well. In terms of, for this data set, many data sets do not, so other kind of data sets for identifying classification of abuse are sometimes not, they do not always include mentions of family members. In this case, it did allow for that. So it wasn't just a personal mention, but also for family members. So here is where we kind of swapped out certain family members. As you can see, we probably could have added a little bit more here for son, daughter, sister, something, maybe papa, other kind of ways that people refer to their family members.
Thanks, Isabel. Thanks, Whitley. Very cool getting some insights into the data augmentation process and the transformation function. So naturally, whenever one begins the modeling process, it's important to build a baseline model to compare your optimal model's performance with. What was this decision behind the baseline model you used?
Sure. So our baseline model. So SVMs are really known to kind of be, they're kind of great and used commonly as kind of a baseline model for comparison and reiterating later. We also referred to the paper that developed this task data set. Their best classifier was a support vector machine. So we decided to use that as well. So here, this is their table of their class-specific F1 scores. You can see on the test set here, their SVM used, it had an F1 score of 0.53. So we decided to go ahead and use that. And we used kind of the same parameters. So we used a linear kernel and one versus rest. The one thing that wasn't as clear in their paper was all of the feature engineering. So we have done more work in terms of, or at least we probably did a different preprocessing or different feature engineering exploration. So
very interesting. So what were the final features you decided to use in your model?
Yeah, so kind of like what I mentioned before, here on the left, I just have sklearn's like pipeline for all of the different things that pipelines that we wanted to explore. Our final features included using the Vader sentiment score. So Vader lexicon is something that is specifically great for social media because it's able to, you know, in their dictionary, in their lexicon, they have valence scores that are based off of emojis. So that's great. So a smiley face versus a frown face versus a winking face, as well as some of slang laden terms. So things like sucks, if you have it spelled S-U-X, you know, there will be some sort of valence to that. And we did the Vader sentiment score before the pre-processing to really get, you know, the elongation, the number of exclamation points, all caps, all of these things like play something into sentiment. We also added binary flag features that included the presence of commonly abused drug terms and the presence of emojis commonly associated with drug abuse. So obviously this it required us to kind of explore the data set, and it really having us as a person, you know, figuring out, oh, what do we see based off of our training set in terms of the emojis and emoticons. And then we also made a tag for the co-occurrence of both chemical and disease entities. And we used open source named entity recognizer from SciSpacey. So for BC5CDR, and then we also did we did use term in frequency inverse document frequency of tokens, unigrams, and bigrams. So in terms of our feature engineering, so for our training, you know, this was, we used our own augmented data set to fine tune and determine which features to keep. So and yeah, I think many of us are NLP scientists who might be on the call, but just as a recap for TF-IDF, you know, the gist of it is that it is still a count-based metric, but it puts more emphasis on rare words. So that was why that was used. And below you can see the scoring based off of the final submission of our SVM to the task system. And just as a background again for the task system, the way that these tasks work is that they may release the training and validation set, but then you have the test set release and you have 4 days to submit maybe up to 2 or 3 systems. So in our case, we submitted 2 systems, our baseline system and then our final pipeline, classification pipeline.
That sounds great. Thanks, Isabel. I understand that your system for the social media mining for health utilizes other data sources as well. Can you tell us a bit about that?
Sure. So we decided to collect outside data sources for our unsupervised fastText word embeddings model. So here is an image of that table from the paper. So we use the Twitter stream archive. And then we also used tweets pulled using the original drug terms listed. So in pulling this, we used the API and we essentially used, I only bring this slide up again to see, you know, these were the keywords. So with Twitter API, you can actually query based off of language and other types of attributes. You have to pay if you want to get things that are geospatial. So we don't have that information, but we did query for tweets and we wanted newer tweets. So of course, anything from after our, you know, the last date of our tweet corpora, we kind of queried to get more tweets. We also used the UC Irvine drug review data set. So on their machine learning repository, they have both the druglib.com data sets as well as the drug review data sets. We also use the consumer health answer question corpus that is from the National Library of Medicine. And then we also augmented that with just the first 1 billion bytes of English Wikipedia, just to have not only Twitter or health social media type text to kind of handle some out of out of vocabulary. So
Very interesting. Thanks, Isabel, for that. So how were the tweets from the Twitter stream archive collected? For example, were they queried for certain words related to drug use using the O'Connor's drug list? And were they maybe extracted from key areas of the country where a lot of drug abuse occurs?
Our purpose of, to answer your first question, we did not query for the Twitter stream archive for certain keywords related to drug abuse using that O'Connor's list, because we wanted to create rich embeddings. So we used all of the tweets, and that's how we were able to have 6.5 million sentences in our final corpora. So we didn't query it. In terms of your question for curious of key areas of the key areas of the country, we were not able to because we didn't use geospatial querying in our Twitter API, but we did subset it to be English specific, and even within our own corpora. So here you have the consumer health question answer corpora. I have an example down here on the left. As you can see, this question here is from Australia. So we limited it to English, English specific. So, and then on the right here, this is just an example from drugreviews.com. So the motivation for creating custom embeddings really came from my own thesis, where I noticed that working with Wikipedia and medical notes was really helpful in going into domain-specific queries. So for instance, in this case, in my case with Wikipedia and EHR notes from both Mimic3, which is a repository that has clinical notes, as well as NYU Langone notes. If I use the Wikipedia from fastText Corpora, we see for DNR, I don't even understand what these acronyms are, but for DNR on the left, you see that the first cosine similarity is going to be DNI. That means do not intubate. You also see things like CMO, so comfort measures only, things that are commonly around for for mortality and what you would see in EHR data sets. So we kind of did the same. And also our reasoning for using fastText was because, one, it's really efficient and really fast, but also, I've learned this in school. We always say Word2Vec, Glove, and then kind of fastText as the best. And the reason for this is really the enrichment of subword information and how it because of the subword enrichment, it allows for help with out of vocabulary instances. So we can dive into that later. And then Whitley, I kind of wanted to see, in terms of your term, so how we evaluated this embeddings was very much qualitatively. So Whitley, if you have anything to say for this slide, this here is just us looking at the nearest neighbors for certain slang terms.
Yeah, just adding on to this, I think this was incredibly important to be able to do these custom embeddings, because we, when you think about the other embeddings available and you're looking at drug names specifically, see in this example, when we then look at slang terms like perks or oxys, none of those were actually then associated with the proper drug terms. However, on the left-hand side, you do actually see, so even when using some of these abbreviations, it was actually close to and similar to the actual proper drug term. So perks, it was actually close to Percocets. And so oxys were close to oxy and oxycontin and oxycodone. And so all of those are similarly grouped in similar medications. And so that was, I think, very important to be able to do that with the custom embeddings.
Very interesting. Can you guys tell us a bit about the build of your final text classifier now?
Sure. So, I know that it's already 2, so I'm going to kind of quickly just explain our final architecture. So, again, CNNs, I kind of mentioned this earlier, they're really great for short text classification and when things like orthology are important, which we found, in the use case of tweets, that's the case. We did do pre-training and fine-tuning to make our custom embeddings into token to vector weights that would be inputs to our embedding layer. Initially, we did, investigate a 4-layer CNN with average pooling, and then later I switched the architecture to be a hierarchical 2-layer CNN with parametric attention, and then stacked with a unigram logistic regression. And for the CNN aggregation function, I switched it to max pooling. Our embedding layer was really interesting. So what can you embed? You can embed a lot of different things. I think, we embedded things such as linguistic features, part of speech, and word shape. So right here, I kind of show what that looks like in terms of what can be included in the embedding layer. So, and then here's kind of an outline of what that text classifier kind of looks like. And then the validation performance using the augmented data for this deep learning architecture before the post-processing applied.
So Isabel, you had mentioned that you changed your architecture. Why do you think the 2-layer CNN architecture with max pooling was better than the 4-layer architecture with mean pooling?
So I would say that I just took, I really like to take a best practices approach and do a lot of literature review. So Zhang and Wallace, they have a paper that is called the practitioner, it's like 4 CNNs for sentence classification. It's a practitioner's guide. And in that work, they describe that for an aggregation function, 1 max pooling has been just shown to be better than mean pooling and even 1K max pooling. So that's really the motivation behind changing it, is just doing more literature review, especially because it was a competition and there's time constraints. So if anyone's interested in that paper, I'll make sure I link it later. So
So I understand that your system also includes a post-processing pipeline where Snorkel is also utilized. Can you speak a little bit about the strategy behind that?
Sure. So initially, our goal was to enrich our training data with a supplemental tweet corpus. So those tweets that we had used the API for with the keywords, we wanted to utilize our subject matter expert, Dr. Whitley Yee, as well as the annotation guidelines to develop a set of heuristic rules and perform noise-aware labeling using codified rules in Snorkel. The result ended up being that we had a low coverage of rules, and we actually had really low label accuracy and coverage. So we decided to update our goal and use a subset of heuristic rules that met a criteria that we thought was good. So an acceptably high empirical accuracy. For our threshold, it was 65%, and use that as post-processing.
Thanks for that, Isabel. So question to you, Whitley. What heuristics did you take into consideration when you were building the post-processing rules?
So in terms of clinical considerations for this, within each of the classes, there's a few themes that repeatedly showed up. And so we try to capitalize on that. So for example, in the abuse class, many of those, indicated that somebody was pleasantly surprised they found a drug. Or it Another example would be manipulating drug absorption. So taking a drug with something that you know is going to increase its absorption or increase its effect, like taking Adderall with an alkaline drink or baking soda, or taking something on an empty stomach or with caffeine. And so the challenge though then was making sure that we had the correct or comprehensive libraries of synonyms then. And so if we wanted, you know, another thing would be, you know, mention of a medication with a clinically inappropriate route or indication. And so to create this heuristic, we did have to create libraries then to define what are all the appropriate routes for each drug, because one route may be appropriate for one drug, but then that's not an appropriate route for a different drug.
So also, very interesting. Can you also provide us with an example of a tweet where the post-processing label changed the rule for?
Sure, can do that as well. And so these were some examples of where the post-processing rules did actually change what the model predicted. One example for, you know, is, you know, took my Adderall, make me buy a desk and a mouse so I can study better, hate myself. And so that was initially abuse, but because of the rules, we then labeled that a consumption. Because buying a desk and a mouse, for example, to help you study better is not an indication of abuse for taking Adderall for that reason. And so these are just a few examples of how the post-processing rules overrode what the original model predicted.
Interesting.
Yeah, I think so. I know that we are kind of at 2:05, so we do have a little bit more, but I'm not sure if we should. Seth, do you think? I guess we'll wait until the end to kind of answer some of the other questions. I know someone had asked to kind of be voice labeling. Here, I just wanted to show, you know, when we're turning logic, you know, this is how I would codify it. So this is just one of the rules. And then also, I wanted to kind of shed light on kind of, you know, in terms of us developing the heuristic functions, we had a lot. And as you can see, we really only had a few selected afterwards. So we had tried our best, but unfortunately those were not done. In terms of the way that we selected our labeling functions is that we did have them be applied ordered by decreasing precision. So the way you can imagine this process is that the labeling functions are applied one by one to the tweet after it's passed through the model. So each labeling function has the ability to override the class label predicted by the model or to pass it to the next labeling function in line. The final class label is set by the first labeling function to override, or the original predicted label is used if all of the labeling functions pass. So that's just kind of how that post-processing pipeline is. And here, just to kind of give some context, this was on our official test set. So I realized before I was saying test set in terms of our, we were using the validation set, a subset of the validation set to kind of fine tune our features, not the test set. So the test set was released, and this is where we see, you know, a lot of the rules that we developed, looking at our training data set, such as rule airline, it was not actually applied, but you see other things such as the rule of pet meds were applied here. So 6 times on our on the official test set, which is about 2,000 tweets.
That's great. So can you kind of break down the performance of your award-winning model for us?
Sure. So even though it was winning for the competition, but the scores were still quite low. So here's the actual official, you know, winning text classifier. Some of our other people in the competition did use more advanced architectures, but we were still able to, you know, win with this 0.51 F1 score, which, and then, you know, our baseline model here has 0.49. If you look on our actual validation set, you know, our scores were a little bit higher. So for sure, you know, we probably were, there was not enough generalization happening. So.
Interesting. So question for you, Whitley, what kind of trends did you find in the data that was mislabeled?
So one of the things, so abuse tweets were commonly labeled either as mention or consumption. And as Isabel mentioned, you know, there may be a bit of potential overfitting on some of that. We did notice that the model struggled to classify certain instances of abuse of a relative or close friend. And so for this labeled data set, abuse counted if it was the user that indicated abuse or if it was a very close friend or relative, because research or study do show that the abuse is more likely, or people are more likely to start abusing medications if they are exposed to it, or if a close friend or relative, for example, is abusing, then it's more likely. And so that was something that was seen of interest. And so our model did not pick that up very frequently. The other thing is just, it's really hard. Of all of the mislabeled abuse tweets, specifically benzodiazepines, and among those specifically Xanax was one of the most commonly mislabeled. And this is because Xanax is just really a part of, you know, common everyday speech. And so it's just used as a figure of speech. And it may, in this instance, so an example of the tweet there, Xanax is actually used as an adjective, you know, and so this is not really referring to the drug at all, but this, for example, was categorized as abuse. And so this one, you know, just says, if one more entitled Xanax mom yells at me. And so in this case, the model picked that up as an abuse rather than as a mention, which is what it should have fallen under. This here, this is specifically looking at the test set, and so we don't have the ground truth labels, but it does show like what the model was less confident on, and I think that indicates on, especially, you know, the tweet on the top says, you know, a year ago I was flying to Greece high on diazepam for my fears. And so it makes sense that it was not as confident on this one, because it really should have been labeled as consumption. Because although there is the mention of being high, which is an abuse type drug effect, it happens in this case to just be a side effect of taking diazepam appropriately for a phobia of flying, which is a medical indication and something that is medically appropriate.
Yeah, I think that this is really interesting to show too, because it does show that there were instances where the model had, you know, there is high confidence or high probability. But in this case, you know, we see, we in order for us to get our label, we take what the maximum score was from the model outputs. And here the maximum score is only 0.379 for abuse for the second tweet. How tired of Drake am I, you ask? 2 bars of Xanax, tired of Drake. So these are quite interesting in terms of error analysis. I'm not sure if we should dive into this. I know that we are very close to time, and I do want people to be able to ask questions. You know, so.
Yeah, I think we could just take questions.
Should we start taking questions?
Yeah, let's do that. This is Seth. Let me first start by voice enabling Sai so that he can ask his question. He or she can ask the question directly and discuss that with you. Then you have a whole set of questions in the Q&A. Attendees can use the Q&A to submit questions for the speakers. Sai, you on?
Sure. Am I audible?
Yeah.
Yes.
Okay. First of all, thanks for this great session. My question is, I think somewhere around slide 45, maybe 44, you were talking about the embedding layer, probably the first layer of your network. And I think you said you were able to embed multiple things, not just the raw text.
Yeah,
Yeah.
yeah. So this is actually where you can use things like feature hatching and so forth. And actually, I think we can go into, so what's great about this is that we do have our code on GitHub. So if there are questions later on, I can kind of walk through exactly how that embedding matrix is done. So I think it's kind of a quick way to do word embeddings is that you kind of use things like part of speech and tagging. And what we used the think package as well as Spacey in order to do that. And this is something very, very easily to do in the pipeline. And it's something that you can embed. I think for future directions of this embedding, we'd probably want to even add something at the character level.
Got it. Yeah, sure. So along with your text, you also had these pause tags like num, propen, and all these things, proper noun, and all that stuff. And all of it was embedded together. Is that correct?
An embedding layer. Yep.
Beautiful.
So and then we concatenated it. So yeah, we'll have to dive into, like, I'm really, really happy to kind of dive into some code examples too, but you can imagine we have our text layer, which is going to be initialized with those token to weight vex. So for each word of text, there is that 300 dimensional word. And then how do we concatenate it with the part of speech tags? Those are a much more denser embedding matrix, but we were still able to concatenate all of that. So
amazing. Yeah. And I had a second question. You said you were in a competition, and did your competitors use something like BERT or DistilBERT, some other advanced models, and you were still able to beat them because of all your pre-processing and custom things that you had done?
Yeah, so that's true. So they did use that, and we were still able to beat them. I think that some of it is just the CNN itself, using that architecture. But there is a paper that just came out on this data set where they use BERT and they have a higher performance than us. So within the competition, within the competition, we won, but I think that future, there are people who are doing more with BERT and more advanced. I think the biggest thing is the training difference. So we did explore training with BERT, and I was training for 3 days. It's just a lot of computational power. And I really think, taking a practical methodology, and also I think CNNs for text classification is really, really cool and has been really a new, I've been seeing it a lot more for this task. Maybe not so well for named entity recognition and so forth. Something we do want to do in the future, though, is do explore more advanced embeddings. The embedding layer that we have is actually quite simple. I think that what we could do is do more language modeling or add an auxiliary task where, we have the embeddings try to predict the next character or word. I think that would be a really great next step for us to do something that's more state of the art or more advanced.
Got it. Thank you so much again.
Thank you so much for your question.
Why don't you go to the Q&A, and then I have Gautam has raised his hand, and I'll call on him in a moment.
So there was one question there I could go ahead and take about a scenario where if medications are taken more than X amount of doses, then that could be considered abusive. Otherwise, it could be normal. And how do we handle that? And so in this case, we didn't actually take into account the dose of a medication in terms of impacting the label of whether it's abuse or not. So theoretically, you could create a library and actually determine what is the what's the minimum dose range, what's the appropriate dose range for every medication, and then if you see something outside of that, it would automatically be abuse or misuse. However, there's limits to that because that's really at a population level, and so that's looking broadly at all the this is the very max that this medication never be above that, but for an individual person, it could, a dose within that appropriate range could still be inappropriate for them because it's really based on what an individual is prescribed. So that still just kind of gives you, it doesn't give you full information, and I think it's something to look at. But in Twitter too, not that many people actually listed their dose. So we only had a few tweets where they gave specific numerical amounts. Otherwise, you really didn't have a lot to go off of. That's a good question, though.
Well, all right. I've voice enabled Gautam. If you are able, go ahead and ask your question.
Sure. Can you guys hear me?
Yes.
Okay, great. So I'll start with this one, with this very slide. So I have used CNN for image classification. So can I think this embedding layer, which is very similar to an image, so which is where your convolution would be applied?
Into image. So I will say that my focus in my master's thesis was predominantly on natural language processing, although I did take some image text classification, or I did take some in my first deep learning class on image, but I'm not really an expert in the image part. I'm sorry, I'm not sure if that's like a great answer to your question.
No issues. So second question is in two parts. So one is, I see that you have used SVM for your base model. So is there any kernel preference? Did you try variety of kernels, or do you have any kernel of preference?
So that's a great question, because really when you're developing a baseline, you want to hyperparameterize as much as possible. I will say that in ours, we really used a very basic predefined set. You just followed the paper. In our linear kernel, we could have done a lot more in terms of developing that, but we didn't really explore the kernel preference. But that is a great question. So I do think, yeah, thank you.
And yeah, go ahead, sorry. I keep interrupting.
Oh, that was mostly.
Okay. So last question. Can you go to the slide where you have this confusion matrix? I mean, classification report. I saw a very interesting observation. Yeah, this one. So if you see here, the unrelated, right, the support of it is very low. That's 104. But if you see the F1 score for it, it's 92. So do you see the influence of training here? Because even though the support is very low, you still have very good metrics for this.
Oh yeah, this is a really great observation for the unrelated class. So this class that is very interesting, just because this class only represented 4% of our data set. So and I think actually, we don't have, so something interesting about this task is that they didn't provide us the ground truth for our test data set. So this is the validation performance on their validation data set. But I'm really curious as to if unrelated was mentioned as much. So thank you for interesting observation.
Thanks.
Not so great for our abuse class, though, the main class.
Want to go ahead with questions from the Q&A?
Sure. So let's look at some of the open questions. Let's see. So it's not very clear how you're managing the text preprocessing workflow. Do you have Apache Airflow or another framework to handle acyclic processes? So what we ended up using was actually Google Cloud Platform, setting that up to read in all of the huge corpora that we have from, I'm thinking of like AWS S3, but whatever the Google version of buckets are. And we really just used their Jupyter notebook. So we didn't have anything super fancy. But that's kind of how we did it. Again, this is a process for a competition, so this is why it's not super industry level or so forth. I hope that answered your question, Slava. So in the stage of the extraction of the entity recognition, so here when we evaluate the quality, this was actually just done by looking at looking at kind of what that size spacey pipeline already has for their drugs. Their F1 score is pretty good, and it's a really practical framework. And just qualitatively seeing, did it do well when extracting chemical? Chemical itself in that corpus BC5CER is actually not the same as extracting drug, but we did a more of a qualitative check, and this was only done in terms of our baseline feature engineering process. So that was to Jason's question. And then I have on which basis did you classify the hashtags? So we actually didn't classify hashtags in any way. We only used it in our preprocessing to add those annotations around it. And the way that the annotations were done was just through the ekphrasis preprocessing. For Xenia, for feature selection, that is done, should be done on the training. So actually it's okay to do feature selection based off of a subset of your validation set. What's really important is that you do not do it on your final test set. So to do it on your dev set, that is definitely okay to do. So in Daniel's question, how do you handle misspellings and bad English? Was there some sort of normalization? Did it indicate possibility of abuse? So this is fascinating. This is something that I want to look more into because I mean, I have terrible misspelling, I'll be honest. and I think that there are some, you know, there are some things that we wanted to look at in terms of bad English, if it's for abuse. We're kind of curious as to really evaluating the data set more, because there were subjective hints where, you know, I noticed in the data set, I know this song lyric, this is something I listen to, and it's the model is thinking of it as abuse when really it's not. This is a lyric, right? And you know, maybe if you compared it to a model in terms of standardized English, some of the song lyrics would not rate well. So I think this is something that we would have to do further analysis on, for sure.
Let's take a live question from Keisuke Inoue.
Yes, thank you for the interesting presentation. I'm just curious on how much impact to the performance was made by the embedding. Do you have any insights, like how it contributed compared to if you were using like existing general off-the-shelf word embedding?
Yeah, so that's a great question. So this is something that I know based off of our testing on the validation, we actually did use. First, we just used English embeddings, and then we also used the Glove. There is a Glove open source of Twitter embeddings. The one data set we did embedding that kind of exists, there's something called TWIMED. We didn't get to evaluate it. When we were doing the modeling process for the CNN, we saw a huge improvement when we used our own custom embeddings. Another thing that we actually saw, but we didn't end up using it later because we wanted to open source all of that, was that I saw an improvement when we actually added EHR notes as well. So using the Mimic3 data set, but because we wanted to make sure this could be like open source and so forth, we really wanted to just kind of stick with our corpus that's in the paper. But using EHR notes would also improve that. And we validated this just by looking at our validation set. I don't have the exact numbers of improvement. They're really small, but still significant for that abuse class.
Great, thank you very much. Could you give me a tool or a library that you might use for the for building that embedding?
fastText all the way, I would say. So they are extremely efficient. So fastText and StarSpace are tools that I recommend for building your own in-house embeddings. So those tools I recommend.
Got it. Thank you.
Thank you for your question. So I know that we're at 2:30. Seth, what do you think?
If you want to take the rest of the questions pretty quickly, that's fine. For those attendees who don't want to stick with us, that's okay. We'll be posting the video of the session within a few hours after it's all processed and so on the NLP XING YouTube channel. But why don't you go ahead and tackle the rest of the questions that you want to from the Q&A, quickly if you can.
Sure. So for size question, we already answered that earlier through one of the live questions about the embedding layer. In terms of the applications of this model, so this is where we really, so right now it's really for surveillance. So we actually have some slides to kind of answer this. We thought we would have more time to kind of go through through this. But in terms of broader implications, substance abuse is a major public health crisis. So I'm going to ask Whitley to help join in this, but these are not applications of our model right now. But this is where we see the importance of using NLP, using Twitter, using social media, using things available to really think about the problem of substance abuse. So Whitley, if you want to take this one.
Yeah, and I'll keep it brief. The CDC has listed improved and timely surveillance as one of the most critical factors to helping really fight drug abuse and misuse. And so right now there is actually most of the data that we have in order to know if current public health efforts and policy changes are effective, there is significant lag time. So when we are trying to look at mortality surveillance data or hospitalization data, especially mortality data, it can take up to 6 to 13 months before you have that data. So you can imagine it's very long turnaround time to try to iterate on something and understand if your efforts are actually working. And so that's one of the most important things is there a faster way to get data and know whether trends are changing and whether anything you're doing is having an effect. And the other thing is right now, the data that we collect, it's only looking, it's just hard numbers in terms of, what the mortality is or what the morbidity is. And so I think Twitter data is really interesting, or just social media data in general, because it potentially could also allow you to look at user behaviors too. So not only maybe get faster information on how potential, public health efforts or interventions are working, but maybe try to figure out at a very, regional or local level, what behaviors may be leading to abuse, and maybe then develop more targeted interventions. So a lot of potential here. It's an exciting area of research, for sure.
And so Bob, the applications of this model, we think that there are impacts to it, kind of what we discussed. These are some broader implications, but right now, I wouldn't feel comfortable deploying the model in terms of surveillance just yet. So kind of next steps for us is that we really wanted to really do some data evaluation. So looking at ground truth levels for abuse and misuse to kind of differentiate between, high subjective hints versus maybe some lower confident ones. So things like someone saying, they want a Vyvanse soy latte or something like that, versus someone who is explicitly saying, either asking around for trying to find certain medications and so forth. And then just doing more descriptive analysis with subject matter experts to further categorize tweets, for sure. And then let's see, the next question. Can you please give us the GitHub repo name? Thanks. So the GitHub repo name should be RX space SMM4H, but I will provide, let me provide the details. I wonder if there's a way, Seth, for me to do a follow-up with that repo, just instead of like Google, like pulling it up now, or I could pull it up now.
Yeah, I will be posting the video link to the different meetups that have sponsored this program, and I can include your GitHub there.
That would be great. Great. So did you use GPU for training? If yes, config the details. So we did not. So we used the Think package that comes from Explosion AI for our CNN. When I was using the BERT, when I was exploring BERT in the very, very beginning, I did use GPU, but because that was not something submitted, we don't have that. I can give you the configuration of just what the CPU specs are. So for instance, our fastText embeddings here on my MacBook trained really, within 32 minutes, but on my colleagues, it was gonna take like 10 hours. And that's because I have a custom made, one built with the most RAM and a lot of like different specs. So I can kind of give you those config details if interested for size question. So what were the names of those tools for Jim Collins? So in terms of a list of all the tools that we have that in our GitHub. And I'm not sure exactly which tools, but some of the major libraries that we used were scikit-learn, Allen NLP, Think, along with Spacey, fastText, and I think those are like the biggest libraries. The second library that I mentioned for embeddings was Starspace, but we used fastText because we did word level. Will this be used to flag individuals as drug abusers? So no, this is not going to be used for that. Whitley, I don't know if you want to mention anything about that, just to kind of clarify, because there are ethical concerns that people are curious about.
I mean, I think just ethically, this would not be an appropriate use of this at all. But even just thinking about the validity or accuracy of this, I mean, this is not going to, this would never really be accurate enough, or it's not really designed to be accurate at an individual level. I mean, just looking at those kind of tweets, there's no way to make a prediction at that granular level. It's more so, can we identify trends at a population level, or maybe like a specific geographical region to know where to target interventions or efforts. But this would not be something that I think would be effective, or even definitely not appropriate at an individual level. Absolutely.
I think it's probably a good time for us to wrap up today's talk. We've gone on for an hour and a half, including all the Q&A. We often do have a lot of Q&A, and today was some of the most. It's great that people took such an interest in your talk that they wanted to know more. The mark of a good talk is that you have a lot of questions. So thanks very much to our speakers for today. That's Isabel Metzger, Whitley Yee, and Trevor Mitchell.